the period of that cycle. So now the least common multiple, LCM, so the LCM, least common, I'll explain what that is in a minute if you've forgotten or don't know, is equal to the least common multiple of the lengths of its component disjoint cycles. Okay, so assume that these are disjoint cycles, right? And the product of them gives you the permutation you're talking about. So this is sort of general form, right? Just a permutation. And the order of the permutation. Okay, so P to the K equals E. Right? The order, now permutation is just an element, right? It's an element of some symmetric group. So it as an element of the group, it will have its order. So let it be K, the smallest positive integer, such that the element raised to that power, K, is E, the unit element, right? So this will have an order. Let it be K. We don't know what it is yet. Let it be K. All right. Is equal to the least common multiple, LCM, of the lengths of its component disjoint cycles. These are the component disjoint cycles, since we've got to say n of them. So we have to prove, show that this is, the LCM is equal to it's the LCM of these lengths, okay, so of length 1, of length 2, length 3, length n, okay. We have prove that prove that K, this is the order of the whole permutation, prove that K, its order is the least common multiple of all these lengths, the lengths of all these cycles. Okay, so far? Now look, we can immediately change this because of the theorem we've just done. Instead of talking about lengths, we can talk about the orders, right? So let's just call this K1, K2. It's the order of the cycle, because cycles are permutations, and hence they are members of a group, a symmetric group, and therefore they have an order as members of a group, right? So just rewrite these lengths as orders of the permutation, but it's a special kind of permutation. It's a cycle, right? Dot 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 dot. K to the n. All right. Now, so this is what we have to show. All right. Now, what is a least common multiple? By definition, what is it? It's an integer, the smallest integer, that all these numbers here divide into. So each of these numbers here, if this is the least common multiple, each of these numbers here is a factor of this number, whatever it is. Okay? So let's say it's L, then it's an integer, right? This integer big L, and it's the least common multiple of all these integers. Right? These are just orders of these elements, of these cycles. So right? Now it's the smallest one. Okay? So if you go any smaller than this integer, one or more, think about it, one or more of these integers here does not divide into this. Okay? So this number here is the smallest one, such that all of these divide into this. They're factors. The smallest one. Okay? And if you go any smaller than that, you'll get at least one of these that doesn't divide into this. So so if they all divide into this, that means that now these k's, what are they? They are the orders of these cycles, right? So for this L, what this cycle, and if you apply it k1 times, well, yeah, after you put it this way, do this. P, what is P to the L? Right? If you apply L, if you apply this permutation L times, what will you get? Well, this will have gone through, so C will have gone through, well, let's do the factors in fact. So let K1 be, I don't know, N1L, and let K2, because these are factors of L, right? That'd be like N2L, dot dot dot, so K little n, oh, that's unfortunate, perhaps I should have, you know, I'll make that different, what do I call it? M, okay, so is that right? No, it's not the way. Sorry. So L is M1 of K, L is M2 of K2, and L is Mn of L. Right? So each of these orders here are factors of L. Right? That's the definition of the least. And this L is the smallest one, where all this is true. Okay? Now, if you apply this permutation here, L times, so you apply C1, this cycle, L times, so you'll get, right? And C2 will have been applied L times, dot, 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 dot. And this will be Cn applied L times, right? So, what is this? Well, it'll be, what is L for this case, for C1? Well, it's M1K1. M1K1. And this will be C2, M2K2. Dot, 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 C to the N, NKN. Alright? Okay, now rewrite this in the following form, so that becomes like C1, K1 to the M1. Right? And similarly here, so this will be C2, K2 to the M2. Dot, 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 and say C to the N of K to the N, M to the N, right? Well, you can probably see where I'm going now. Now look, K1 by definition here is the order of this disjoint cycle, alright? Equal to the least common multiple of the lengths of the component disjoint cycles. Okay, so this K1 is the order of that, right? So this here is just E, right? So you've just got E to the M1. Now similar logic, K2 is the order of this cycle. So again, so that's just E. So you've got E to the M2. Dot 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 dot. So this will be E to the M to the N, right? Now that whole thing, So e to the m1 is still e to the m2 is e, so you've got e to the n, which is still just e, right? So you have shown that p to the l is e. Okay, so that l is well, it's so that l then is some multiple, let's call it q, of the order of p, right? So what we call that? Okay, well, I'll just call let the order of p, this let it be equal to, r, let's say, just whatever. So now that will work if l is, but they're both integers. Okay, so we have to show that q is actually 1 because we want this to be the smallest, right? So how to show that? Is that obvious? We want that to be the smallest one. Now it's the least common multiple, right? So that these numbers are the